All right, hey everybody, we're live on Facebook Live. We'll see people, even if they haven't shown up, they can join in. So Rick Padron here is going to act as cameraman. We're going to flip the camera around. We scheduled this for 3:30. We're running a little late. Unfortunately, a lot of people have already left. We thought they'd stay longer, so mostly what we're going to be seeing is the display of my collection.
But I've got a lot of pictures and video to add to the page.
Oh, there he is. Okay, so Rick's got some pictures and stuff, so we'll add that as well once we put this on YouTube as an archive. Yep. So. All right, so you want to do camera, and we'll just start over here.
Let's do it. All right.
So this display very much is in chronological order in this space. So we start off with Edison's Menlo Park era. We'll see everything from the first wire buried below ground and excavated in the 1930s for electric conductors at the Menlo Park campus, to an early light bulb experiment that was possibly broken on the laboratory bench and fragments saved, to the drafting set that was used by Francis Yale at Menlo Park that descended through his wife and is now in the collection. You got a picture here, early picture of the crew at Menlo Park on the front porch. Early example of an Edison light bulb with the first wood screw base. These were only used at the Menlo Park campus. They never really made it outside into an installation. Some cabinet cards of different Edison high-ranking employees. Charles Clark, who was the chief engineer of the Edison Electric Light Company. Edward Johnson, who was the president of the Edison Electric Light Company. And there's Mr. Edison himself. Slightly later, light bulb, later 1881, we call it a plaster collar. This is a winding from one of the dynamo field coils of a dynamo, one of the 4 dynamos used in the first installation Edison ever sold of his system on the SS Columbia in February through May. They built out the system and launched it in May, and that is a winding from the dynamo that has survived. 2 dynamos were scrapped. This is a piece of that. The other 2 are in the collections of the Henry Ford and the Smithsonian. This document is the original expense report submitted by Charles Clark, chief engineer, to Sherborne Eaton, who was the vice president of the Edison Electric Light Company. This was the budget report for the building of Pearl Street, the first central station in the country for electric lighting. And then we have the Edison effect lamps. So the Edison effect lamps were a testing device to help monitor the darkening of the light bulb in an effect to find ways to stop darkening, which ruin efficiency. There's a separate plate of platinum in each example. Years later, this principle was applied to invent the vacuum tube. So it is considered that the Edison effect lamp is the grandfather of all modern electronics. Here on the back wall, we've got some original photographs. Here we have the Sarah Jordan boarding house, which was on the Menlo Park campus, where many of the employees lived, the single employees. And we see people in this picture, including William Hammer, and that's the only one I can make out from the distance I am. Below here, we've got a picture on the second floor. This is called a cyanotype, which is the same type of process used for what we no longer make in blue, but call a blueprint. They were at one time actually blue. And this is the second floor of the Menlo Park lab. You can see the light fixtures, which are converted gas lamps to hold their new electric lamps. Sitting in the picture on the right is Francis Yale, who was one of the youngest employees, and wound up writing a book on his experiences and became one of the most noted Edison employees. Then we have here a photograph of the first lamp factory on the Menlo Park campus. This was a building that was converted from manufacturing the Edison electric pen to manufacturing light bulbs. So this is the first light bulb factory in the world. And now Rick is going to identify the name of each person in there.
Get back to you on that.
But next time.
Do you have some strapping or some duct tape or something that you can make like a handle type deal box? We had shotgun
This here is the front of Edison's laboratory.
or ducting. Yeah, packing paper. All right, I'm sorry.
In the center there, we have Mr. Edison, his kids. The old man there is Edison's father. To the left is Francis Yale. This is Ludwig Bohm, who was the first glass blower, who made some of the first successful light bulbs in the world. Yes. Up here we have the machine shop in Menlo Park. So this is an arc lamp. Most of what is here are incandescent, but prior to incandescent, the first commercially used lighting by electricity was an arc lamp. It was originally a European invention. It came to the United States with the work of Charles Brush, who turned the arc lamp from an experimental device to an actual utility. And he was able to light streets in New York City prior to Edison through arc lighting. This is an original Brush arc lamp from late 1879 to early 1880. Here. So the next part of the display goes into the concept of distributing power, which is a major portion of making the lighting system successful. So what we have here is an original drawing, probably to be drawn by a professional patent draftsman. This is dated and signed by Edison's patent attorney, Seeley, and this would have been a diagram of how Edison's three-wire power system works. This is a cool piece. Here we have some propaganda, probably paid off by the gas industry. People were somewhat scared of the concept of electric lighting, and Edison, through his powerful and wealthy investors, had gotten permission to dig up the streets of New York to bury underground conductors. And what better way to scare people of the devil through the wires underground than a scene like that? This is a similar piece, although I think this is probably my favorite.
I like that.
And it's a little later, 1889. But they were still trying. By 1889, the last piece was 1882. By 1889, they would have surely had, you would see a lot more electricity and electric lighting available. So the propaganda probably had to build, and this was a propaganda piece. It made it look pretty scary. If you think that's scary, imagine having gas lighting in your house and no CO2 detectors.
Yes.
So to sell energy, Edison had to develop a meter. And this first meter, which first hit the market in 1882, this example dates somewhere in the mid to late 1880s, used an electroplating process. So these jars would have been filled with a conductive solution. The incoming power would have flowed through these plates, transferred zinc from one plate to the other, and they had a formula to calculate how many lamp hours it took to add, say, an ounce from one plate to the other, and they would measure it weigh it at the end of the cycle and bill from there. There are two jars because it was so crude and accuracy. One second. So this is an original underground splice for the Edison system. The Edison tube was a conductor that was built with a cast iron or an iron outer jacket with copper conductors inside. Rope was wrapped around the conductors to separate them, and then filled with tar as the final insulator. These were manufactured in 10 and 20 foot sections, and they had to be spliced together. So every 20 feet minimum, you would have one of these connectors where they would have made the connections, put the lid on top, bolted together, and filled it with tar. The tar has been removed from this one substantially to expose how it works. And then this would have been buried below ground. This was buried in 1890 in San Francisco during their Edison system installation and was discovered again in an excavation in 1979. So this is an Edison Dynamo. It's one of the earlier examples. This machine dates to about 1884. This is a machine that would have been capable of powering about 60 light bulbs and typically driven by a steam engine.
Jen, I don't know where the refrigerator is, but I'm taking this trash out and I have to walk right past it. So okay, thank you. Are you yeah, I'm going to take the trash bag out, which has food stuff in it, and then I can put the rest of that in the bag and handle it. If not, it'll be here Monday morning. Is this anybody's cup?
This picture above shows the same type of dynamo being powered by a steam engine in a mine in Australia. And then we move on to some of the metering equipment for the system. In addition to powering everything, they needed a method of measuring the power to make sure it was within safe range for the light bulbs, measuring how much draw was put on the dynamos. This is a voltage indicator for the Edison system, about 1887 to 1888. And we have the amp meter. This is manufactured by Bergman and Company, who was a business that Edison was a partner in for manufacturing all of the ancillary components for the Edison system, including meters, sockets, switches, fixtures, etc. Above that, we have a Bergman and Company Dynamo Galvanometer. This was designed when using multiple dynamos together in a central station to measure that two dynamos were operating within the same range. This example is missing a lid that would have had wood sides and top and a glass window in front. And then we have the regulator. So this was the resistance box that would vary the voltage of the field coil of the dynamo, effectively adjusting the output voltage. Then we have a larger dynamo. This is a later model between the year of 1877 and 1888. This is a 20 kilowatt. This weighs about 3,200 pounds and has the capacity for 216 candle power, which were a standard size at the time of light bulb.
Just for size, just stand next to it, just to put in reference just how big it is. Yeah. You stand next to there. There you go. Excellent.
Here in this picture, we see actual period use situation with that dynamo. This is actually the power station at the Edison Machine Works where the machines were manufactured. And then we move on to some fixtures. So Edison was really the only system, the Edison system was really the only system that also included decorative, in some cases very highly decorative fixtures in their lineup. And once again, Bergman and Company was the manufacturer. At the top here, we have an early Bergman electrolier, circa mid to late 1880s. This is a Bergman Swivel Arm. This was an arm that was a joining method that was designed by Bergman to allow you to safely insulate the wires as they swiveled within the fixture. This is a simple Bergman wall bracket. This is an interesting piece. This is not known to be made by Bergman and Company, but this was a trouble light or utility light that was made circa 1889 and has some reference to having been used by the U.S. Navy in that period. This lamp, we had a little mishap with the shade holder. That was a replica made piece, and one of the arms came off unexpectedly, but luckily didn't break the shade. But regardless, it did look like this, fully assembled, but this is a very early Bergman fixture, circa 1882.
Those both with wood sockets?
I'm sorry?
Wood sockets?
This probably would have had a wood socket. I'm sorry. Yes, the socket is, the internals are wood, yes.
Okay. All right.
This is a slightly later Bergman table lamp made throughout the 1880s. So these are various Bergman components, fuse blocks in the back and matching fuses. Then we have switches of different capacities, different range of sockets of all forms, from surface mount to switched, non-switched models. This is probably a homemade utility light, but definitely very early, and was found in this form. So very interesting piece,
Very
but
primitive.
not factory, but yeah, very interesting. Somebody made themselves something that otherwise they might not have had access to from period parts. Then we have one of my favorite quotes from Mr. Edison, and where he originally wrote it on this document, which was generally most likely a album page from an autograph album. All right, let's go around here. So this is one of the earliest light bulbs to survive in the world. This is an early 1880 Edison Prototype light bulb that used a carbonized paper filament. And of course this one is no longer working, but any example like this would have been used until it expired as a test piece. And most of them were discarded, broken open to examine the fracture of the filament under a microscope. This particular one was saved and preserved by William Hammer, who was an Edison employee at the Menlo Park Laboratory. Then here we have the first screw base Edison lamp used at Menlo Park throughout the campus. This particular example, you'll notice the clamps are made of very small vices that are actually closed and opened with a screw and made of platinum to hold the filament. Really, really precise work, very, very delicate and very complex and expensive to make. That was quickly replaced by a much simpler method. This example also being from the William Hammer collection. This is the remains of an experimental device from 1880 used at Menlo Park. It was in some ways the precursor to the Edison effect lamps. So very, very little known. The Edison effect lamps are known as the grandfather of modern electronics. In the case of these, this is almost the great-grandfather. When I say there is only one known, and this is it. continue on with the hammer collection. This is a lamp of the late 1881 era. It is the type of lamp that, or it is the lamp that was used at the first lighting of the first central station in the world. A lot of people are familiar with the Pearl Street station in New York, which was the first central station in the United States. However, that started September of 1882. In January of 1882, Edison had completed and launched the first central station, which was in England at the Holborn Viaduct. William Hammer, who saved this bulb, was the employee who flipped the switch on that startup of that central station, and this is the example of the light bulb from that lighting ceremony that he saved. This is also from 1881, an Edison prototype or concept lamp that was designed to work in a mine. And the concept was that it would be submersed in water, a vessel mounted to a bracket to be used in mines, where the concern was that should the bulb break and create a spark, the spark could ignite flammable gases, where in this case, the water would quench that spark and thus make the wine safe. This is also from 1881, very unusual in that the filament, if you can, I don't know if you can get a better angle and see the filament against white background, yeah, is actually made of coiled platinum. Edison's first filaments were platinum, which was an idea that he borrowed from previous collectors, quickly found that it wasn't the correct material for a filament. However, there's some paper evidence or correspondence that survives that shows that in 1881, around June or August, he had a small supply of them made for the use of battery operation around the basket of a hot air balloon. And then finally, in this area from the Hammer collection is a small storage battery lamp. So around this time, Edison was experimenting heavily in multi-uses for the lamp besides just lighting of houses and businesses. And this was a lamp that could have been powered by a battery for use in any type of small discovery application, such as, I don't know, hiking.
Yeah, out on the trail.
Something like that. Yes. We'll skip over the other side. We'll skip over to this because there is one more lamp here from the Hammer collection. And in 1881 also, Edison was experimenting with different envelope shapes. For a brief period of time, they had this theory that here, just move it over so you can see the tip. They had this theory that if the shape of the envelope followed the shape of the filament, it would disperse light better. They quickly found out that had no actual difference on the quality of light distributed, and they went away from what they called a bottle format. This is a very large bottle format. It is 100 candle power. They likely never made any of this in actual production. This would have been an experimental piece used at the just for testing purposes at the lab. We'll come back here. So we have some more Edison examples. Here's an early, the previous two wood-based Edisons that we showed were what we would call a B lamp, or Edison called it a B lamp, which was 8 candle power, or 52 volts. This is the A lamp, which would have run on 110 volts. DC and put out 16 candle power. Below it, we have a lamp that would date to about early 1881. Shows some sign of use, but never had been mounted with a base, likely experimental and testing of filament performance. Here we have the plate off of an extremely early Edison Dynamo, what was known as the long-waisted Mary Ann, and very few survive today. And this particular nameplate is off of one of them. It probably was scrapped, and someone thought it was interesting enough to save a little memento from it. Here we have a letter. This letter is really interesting. Edison moved to New York, 65 Fifth Avenue in March of 1881 to start the business side of his new electric lighting company. This letter is from April of 1881. And in it, he discusses employing Mr. Parham to provide him with the research that Parham had done on the cost of the gas industry supplying gas so that he could compete with them with the electric light. So here, Edison's about 32 years old, 33 years old, and he's going to go up against the gas industry. He has no central station. He has no reputation in the field of electric lighting. In fact, nobody does. And he was pretty bold, and it turned out he was right. This is a pretty special piece. This is an 1882 Edison. We call it 1882. This form was made between the latter part of 1881, most likely well into 1882. However, this example was used in Australia at the first demonstration of Edison electric lighting in 1882. It survives and was well recorded and documented with several different pieces of paperwork, one of which is shown below it in this display, and it's likely the only surviving example of that first demonstration, of which there were apparently only 3 light bulbs in Australia. Below that, we have an early catalog of the Edison system that was produced for sale in England. Here we have an early piece of laboratory correspondence. Sorry, there's a little shadow in the back, but you kind of can, you just hold this back like that. You can see the drawing in there. So attaching the filament in this era was very, very complex and expensive. And this particular document is instruction from Edison to 2 employees, Martin Force and John Ott, who are abbreviated at the bottom, from April 7th, 1883, on an experiment in attaching a filament. This particular method never came to fruition, but they probably tried and didn't work. This is another letter, internal correspondence between Edison and Francis Upton, who led the lamp factory and was a high-ranking employee in the Edison team. And they discuss having Martin Force, another Edison employee, test filament coating mixtures that they were applying to the filament, most likely to reduce the darkening of the bulb. And if we go over to the right, you'll see a fairly darkened bulb that has some unique attributes not seen on other similar era bulbs. And this one is the provenance of coming from the Martin Force family. This is really special. There are actually 4 documents in here on one piece of paper. The sort of purple writing at the top is one document. And then the piece above it, above the label and below the purple, is really the important piece here. When you run a steam engine, there's something called an indicator card that is drawn to record the performance of the engine. And they're metering pieces of equipment that help them draw this. But this is the indicator card from the startup of the Pearl Street station. This is written and drawn on by Edison at the moment he powered up and monitored the performance of the first central station in the United States for electric lighting at 4 p.m. on Monday, September 4th, 1882. Here we see the status of what the Edison lamp would have looked like, its matching socket, in about 1883. We have an interesting document by the mid-1880s. Edison's competitors were basically copying his design, his patent, and he began to sue them. This was a document that was sent to all of his competitors, basically threatening them and showing the proof that Edison had in how he would beat them in court. It took a long time, but by 1892, the court cases were found in Edison's favor, and those manufacturers were ordered to halt production. Here we have a Bergman and Company swivel arm. The bulb that is mounted in it is a circa 1888 Edison light lamp. This is the first, what they called at the time, turn-down lamp, but it has two different brightnesses. There's a small knob on the right that you turn to make it either bright or dim, and it was designed as a night lamp that you could turn on easily, turn down very dimly for reading without flooding too much light into the room. And a very likely type of fixture that it might have been used in that would have allowed it to swivel by your bedside. Let's go there. So here we have some more dynamos. This is an Edison Machine Works 15 kilowatt dynamo, circa 1888. This is the capacity for running about 150 16 candle power light bulbs, which today we would would be equivalent to what we used to know as a 50 watt light bulb. Here's a picture of Mr. Edison himself next to a very, very large Edison Dynamo. Here we have an incandescent dynamo for the Thompson-Houston system. Thompson-Houston was one of Edison's biggest competitors in the mid to late 1880s, and this is a smaller incandescent machine, circa 1890. And here we have the Thompson-Houston arc lighting dynamo. Thompson-Houston started off in the arc lighting business and eventually joined in as well with incandescent, but this is from the arc lighting system of Thompson-Houston, circa mid-1880s. There's an example of a Thompson-Houston arc system installed in a central station. Next we have a Sprague motor. Frank Sprague came to work for Edison about 1883. His interests were more of in motors than in dynamos, which are kind of the same, the opposite, the reverse of one another. Sprague only was with Edison from 1883 to 1884, which he left to explore motor design, and eventually Sprague revolutionized the electric train car industry through inventions of electric train motors. This is a letter to Sprague from Edison, and he's discussing running wires from the Armington engine dynamo, which would be Armington and Sims, a steam engine. That dynamo could have been Pearl Street's, unknown, but likely, into Bergman's test room and installing a regulator box. This is the dynamo of the United States Electric Lighting Company. The United States Electric Lighting Company was Edison's first serious competitor. It was founded by Hiram Maxim. Hiram Maxim had designed his own lamp starting in the early 1880s. He had competed with Edison in the late 1870s with his own designs, and once Edison reached a successful design, Maxim simply stole it, made it look a little bit differently, but basically used the same principles. He moved to Germany in 1884 and wound up inventing the machine gun, at which point Edward Weston, who designed this dynamo, was promoted to chief electrician of the United States Electric Lighting Company. Let's just do a scan of what's here. If we talked about every light bulb in this case, we would probably lose people's interest. If you really want, I can challenge me, I can talk about any one of these light bulbs for about an hour. At the bottom, we have a selection of early sockets. Prior to the turn of the century, there were many different manufacturers who had their own base design, so they were somewhat proprietary. And ultimately, the Edison base won, and it's what we use today. But these are some examples of sockets for alternate bases that existed prior to 1900. Much of what's in this case is all made prior to about 1895. This is the Mather system dynamo. Mather was another competing system. They used a lamp design by Charles Perkins. Charles Perkins started off at United States Electric Lighting Company and eventually transitioned to Mather and Company. The Mather system never gained much traction, and today you see very few. Rick, do you know how to use this machine?
I do not.
Well, the instructions are right there.
I could read.
That is a Perkins design switch. There's actually a paper tag that goes with this. That's how you make contact. That's how you break contact. There's a tag that goes with this. Unfortunately, it's partial, but it's an evidentiary entry for a court case. So this was used in some sort of patent litigation. But mentions Charles Perkins as the creator of it. However, it was likely never actually the design put into production. Since we're talking about meters or switches, we'll quickly go to the Thompson-Houston meters. So there's more than meters. This is an arc lighting switch for the Thompson-Houston system. This is the regulator for the output of the dynamo of the Thompson-Houston system. Then you would have had your voltmeter for measuring the output of the dynamo, and your ammeter for measuring the current draw from the dynamo. All right, let's jump over to the meter case, and then we'll just do a brief graze over the different light bulbs. All right, so at the top we have an Edison voltage indicator. It's a slightly later one than we showed earlier. Sorry, the glass is a little dirty. Let's just try going from this angle. Yeah. Next to it we have another early Thompson-Houston voltmeter. We have another Thompson-Houston ammeter. We have the Slattery induction system ammeter. Wood system ammeter, sold by the Fort Wayne Electric Company of Fort Wayne, Indiana. And then we go to the bottom to some pretty special stuff, or at least this is really special.
Yeah.
The next development in metering after the chemical meter was this. This was designed by Elihu Thompson for the Thompson-Houston Electric Light Company. And this is the first direct reading meter ever made. So whereas a chemical meter required a complex process of having to remove the zinc plates, weigh them, and gamble in accuracy. This meter used a clockworks that was instantly readable by a meter tender. Go to the left, there's a front cover that it would have had with a window to expose the dial without opening it. This was really still extremely complex, not so much to use, but to manufacture. And just after that, within about a year of its production, Thompson designed the rotating disc meter, which is a design that existed, well, until the smart meter. We all grew up looking at them spin outside of our houses.
Right.
The next meter is the Westinghouse Schallenberger. This is the first meter designed for use for measuring AC current. It was designed at Westinghouse by Oliver Schallenberger. This label here says it's a watt-hour meter. That is incorrect. This is actually an amp-hour meter. Next piece is a Slattery lamp hour meter. This was a competing AC meter. Slattery was sued by Westinghouse for his design, and this unit was produced for a very short period, and today we know of very few examples. And then finally is the Duncan design from Fort Wayne, which is what was utilized at Fort Wayne after they no longer could sell. They were the system of which Slattery, they sold the Slattery system. And this is the circa late 1890s, 1895, 96-ish Duncan meter. And then we'll just do a light, review of what we did there, this, and wrap it up. All right, a few cheesy quotes. As Steve Jobs said, his fans are saying, "Oh wait, there's one more thing." This is one of my favorite pieces. This was on the door of the Paymaster General's office at Edison's Orange, New Jersey laboratory. It says employees keep out of this room, so thanks for coming. In the words of MTV Cribs, thanks for visiting my crib, but now it's time to throw you out. Just kidding. Anybody who didn't make it this year, I totally understand. People are still a little apprehensive to travel. We will be here next year. The event was great this year. It'll be even better last year. We'll get the date out quickly for next year, so it's easy to plan ahead. And hope to see you all there. Thanks.
And be on the lookout for the future presentation.
Oh, yeah. Look out for the future
Important.
presentation, hopefully by November, December, towards the end of the room. I'm sorry. I've been talking all day. By the end of the year, you'll be able to see the segment on this meet on CBS Sunday morning.
Which is by David Pogue.
Oh, with David Pogue.
And I have to say that being around here all day, it was a successful event. There was a lot of hype, a lot of heart and soul going into this group. Yeah. And even the cameramen were so excited that they really stayed around even longer.
Expect that.
Yeah.
The cameramen were so excited about this.
Yeah.
And I thought we had almost turned them into a light bulb collector.
Exactly. But wonderful event held by Chad Shapiro. Thank you, people.
Thank you.
Shut up.